And so the thing that's important here is that kind of inherent to doing science is that we need to be able to make measurements. Okay. So in order to make a measurement, what happens is you're going to take some sort of standard unit and you're going to compare it to the quantity that we're going to measure. We do this comparison by going in and counting the number of standard units that are equal to the quantity. And in this process of, counting the number of standard units that give us the quantity we're measuring, this is basically how we get our significant digits or the significant figures. So this process here okay. And so, we can kind of talk about that. So what I have here is a ruler. And this one is marked in centimeters, and then it has millimeter subdivisions on it. And so if we were to go in and measure, I don't know, the width of this little post-it pad or whatever, then, we go through that process where we, compare our standard units to the value and we go in and count. We go, there's 1, 2, 3, 4, 5, 6, between 7 and 8 standard units. And what you'll notice is that with the finer subdivisions, then you can say that this is, 1, 2, 3, 4, 5. So it's between 5 and 6 millimeters. So that's 7.5 something centimeters. Okay. And what we should ideally do is take this gap in between the 5 and the 6 millimeters and estimate one more digit. Okay, so ideally you would divide that interval into tenths and figure out where it is, but I never can seem to be able to do that. So usually what I do is I visually divide it into quarters and try to determine if it's, a quarter or less or a quarter to a half or whatever. But what you need to be careful with is you don't want to write down that it's 1/4, which is 0.25, because that implies that you took this interval and not only did you divide it into hundredths and counted 25 of them. And you're like, I couldn't even divide it into tenths. So you only want to come up with one more digit, whether that's the 0.2 or the 0.3 or the 0.4 kind of things. And so that's usually how I proceed with that. And so we can go in and state that the width of this tablet is 7.6. Oh, that was between Yeah, so 7.5 and between 5 and 6, and then we'll go with, I don't know, 3 or something. Okay, so that's my measurement. And what you'll notice is that this 3, this is the one that we estimated. So this is our, estimated digit. And so then to account for the fact that we estimated that one instead of, exactly counting it, we put on what they call an uncertainty. Okay. And so one of the kind of the standard rules that we go by are that, when you have a device like this, standardly we would talk about that the uncertainty would be plus or minus half the finest division. So the divisions on this ruler are millimeters. And so we would look at something like plus or minus half a millimeter. And so plus or minus 0.05. And then we should put our units on this, and this will just be in centimeters. So putting it at the end implies that it applies both to the uncertainty and it applies to the value. Okay. And so this is what we have. And so a lot of times students are very bothered by the fact that we estimated that 3. But then we put the uncertainty on and said it would be 5 units either way. And so this says that it would go all the way up to 7.58, but it would go all the way down to 7.48. And so we're saying it's between, 7.48 and 7.58. And we're like, yeah, it definitely was in there, so it's a fairly generous uncertainty as our, our guidelines, our standard rule type of idea. Okay. And so then what you want to identify is that our significant digits would be the 7, the 5, and the 3, even the one that's estimated is a significant digit or a significant figure. Now, to me, when I talk about the figure, I envision the whole number and then it's made up of digits, but, I guess other people kind of see it otherwise. I prefer the digits rather than the figures terminology, but it's about 50-50 in the books, to be really honest. So, and like I said, so this is our uncertainty, and it accounts for the fact that we estimated that last one instead of exactly counting it. And so one thing that we want to go in and note is we want to note that there's always essentially an inherent uncertainty, or we might say error, with every measurement.